Hi everyone, in this video I'm going to take a look at an example with matrices. So here's the question. We're given some 2 by 2 matrix and we're asked to calculate a squared plus 2a plus 3i. Okay, so let's begin by calculating a squared. So a squared just means a times a. So the matrix A is already given. So we have to times a by itself. So firstly, with the dimensions, we see there are 2 rows and 2 columns. And when we times them, those numbers on the inside are the same. So we are able to multiply. And the answer will be this by this. So it's also going to be 2 by 2. So if you haven't done many of these before, it's quite useful just to put lines here where you expect to see numbers. I found this is quite useful. Okay, so the first number, this is row 1, column 1. We find this by multiplying row 1 of the first matrix by column 1 of the second matrix. So we're going to multiply each of the numbers in order and then add the final result. So the first numbers are 5 and 5, here and here. So 5 times 5, 25. The second numbers are 2 and 4. Times those together, we get 8. And finally add. So repeat this for all the other positions. This is row 1, column 2. So we have this row is row 1, this row is column 2. So we have 5 times 2 is 10, and 2 times 7 is 14. Stepping down to the second row, we have column 1 and a column 2. So which numbers do we need to pick up? So for this one, row 2 is here, column 1 is this one here. So we have 4 times 5 and 7 times 4. We need to add them. And similarly for the last position, it's row 2, which is this one, times column 2, which is this one. So we have 4 times 2, 7 times 7, and add them. So a squared is 33, 24, 48, and 57. So that's the first term. The second term, we need 2 times a. This is a different type of multiplication. This is called scalar multiplication. Scalar multiplication just means times some scalar, which is just some number, by some matrix. And we do that by multiplying the scalar by every number in the matrix. So just times everything inside by 2. That gives the second term. So 10, 4, 8, and 14. The first term, let's just make a note of this. We calculated a squared. Finally, the third term, 3 times I. So we need to know what is I. I is the identity matrix, which has all 1s on the diagonal and 0s everywhere else. And this is scalar multiplication, which times everything inside by 3. And finally, we can calculate a squared plus 2a plus 3i. We have all the pieces. A squared, we've already shown, is this one. 2a we've already shown is this one. And 3i, we just did this. 3, 0, 0, 3. So finally, add in matrices. We can only do this when the dimensions of each of the matrices involved are the same. They're all 2 by 2, so we can. The answer is also going to be 2 by 2. And the positions, well, we just need to follow each of the matrices. So the first position is 33 plus 10 plus 3. So that's 46. The second position, we have 24, 4, and 0, which is 28. And stepping down to the second row, the third position, we add these up, which is 48 and 8 plus 0, which is 56. And finally, need a new shape. What can I use? I'll just underline. We have 57 plus 14 plus 3, which is 74. And this is our final answer. So for our case, a squared plus 2a plus 3i is this matrix: 46, 28, 56, 47.